we want to start looking now at how we start to graph all the functions we need to in this course. And the first one is the easy one, and you've probably done plenty of these in the junior school, and that's graphing what we call a linear function, which is a straight line. So a linear function we've dealt with a lot of times is in this form, y equals mx plus b. It could be around and be in other forms, which we'll look at those in a minute. But the idea is if we've got this one, this is a nice way to play with it, because we can look at the gradient of our line and our y-intercept if it's in this form, because we know m's the gradient and b is the y-intercept. So for something like 3x plus 3, the gradient's 3, the y-intercept's 3, so we draw a line that goes through 3, so that's going through 3 there, and it also has a gradient of 3, so for every one it goes across, it goes up 3. So it's probably not the easiest way to do it, because there's easier ways to do it. But that's using the gradient and the y-intercept, the gradient or the slope of the line. Or the easier way to probably do it is to plot 2 points, and that's why I would go about graphing these most of the time. First things we want to do though is just about looking at the gradients of lines. So hopefully we're pretty sure on something like this. When the gradients are positive, there it's sloping to what we call to the right. So what we're talking about with a positive gradient is that as the x values increase, and the x values always increase, so we're moving from left to right all the time, is the graph going up? Are the y values going up? Or in this case, are the y values going down? So we have what we call a negative gradient. So in this case, it's a positive or negative gradient, and the gradient's never changing because it's a straight line. But later on, we'll look at graphs where the gradient will change as we go along. But in a straight line, the gradient always stays the same, so we can do that. It stays consistent there. So, but hopefully we realize what a positive gradient means and what a negative gradient means, because we'll do it a lot in this course, talk about those ideas. So positive gradient, the y values are increasing, and negative gradient, the y values are decreasing as x gets larger. So what can we make about the conclusions we make about the slope of a line? Well, hopefully you make these kind of conclusions. Positive gradient slopes to the right, x gets larger, y gets larger, okay, in a positive direction. And as negative gradient slopes left, so as x gets larger in the positive direction, y approaches negative infinity or gets larger in the negative direction. So that's what the gradient means. As I said before, like the way I'm going to be able to draw up a graph of a straight line, and hopefully realizing that it is a straight line, we're in either this form, y equals mx plus b, or in the form ax plus b, y plus c, in that form, or any similar form. Like really we're looking at this case where we've got x to the power of 1, y to the power of 1, and they're either adding or subtracting in separate terms there. So when we do this, the easiest way to do it is to pick 2 points. And it's up to you which 2 points you pick. A lot of times I'll go for the intercepts and find where the cuts of x and y axis, and then go from there. In this case, I've picked 0 and 1. Pick 2 values and sub them in. When x is 0, we get y is equal to 1. So I'm able to get that point there really easily. And when x is 1, we get y is equal to minus 1. And we plot that in, and then draw a line between it. Once you can draw the line between 2 points, just keep your ruler going, and you can keep extending that line in both directions infinitely, because a gradient of a line never changes. So that's why we can do that with consistency, and that's why we only need 2 points. Like if you look at texts or people tell you need more than 2 points, you don't. You only need 2 points, because that gives you your line between, or your segment between the 2 points, and then you can keep extending that in either direction to get the line. So looking at these ones, again, pick whatever points you like. Pick usually 0 for x is a good one to pick, and then you pick 1, 2, whichever one you want. As long as you can get 2 points on the line and draw your line between it. So x minus y equals 1. Again, when x is equal to 0, y would be minus 1, and when y is equal to 0 on the x-axis, x is equal to 1. So that's why I was able to get those ones. And that's why I'll often pick where x is equal to 0 on the y-axis and where y is equal to 0 on the x-axis there. So it makes life easier to try and pick those 2 points, only because I'm substituting in 0 as well. Most of the time it's good, sometimes it's not, but it just depends. So in this case, again, I would have picked x equals 0 and got y is equal to 4. And when y is equal to 0, x must be equal to minus 4. So there's the minus 4, 0, 0, 4. Draw the line between them and keep extending. Again, when x is equal to 0 here, y would have to be equal to 3. So it's going through 3 there. And when y is equal to 0, we get 2x equal to 3 as well. So x would equal 1.5. So 1.5 there. So there's the 2 points. Again, but it could have picked any point. Y is equal to 1, x is equal to 1. See where they fit in. Like once you pick a value, you're just solving a linear equality there. So again, when x is equal to 0, y was 3. When x was equal to 0, y was equal to 0, x was 3. So there's our 2 points. Graph between them. Again, pick values here. Ones that might work here is when y is equal to 5, x would be equal to minus 2. So you pick minus 2, 5. There, and when x is equal to minus, and then pick any, x is equal to 2, y would equal 7. Sorry, x is equal to 0, y would equal 7. Again, pick any point you like. As long as you, sake of x value, sub it in, you'll get a y value. And just do that twice, and it's going to give you the equation of your straight line your gradient, your graph of your straight line every time. The 2 points and graph them. The two lines we should mention, and these are horizontal lines and vertical lines. Now, when we're talking about a horizontal line, if we look at all the points on this line here, we notice something interesting. Because if we look at the point here, that'd be 2, 3. 4, 3, 6, 3, 8, 3, 10, 3, minus 2, 3, 0, 3, minus 10, 3. All the y values are 3. Doesn't matter what the x values do. So really, x's don't have any part to play in this. And really, if we look at it, there is no gradient. Well, the gradient is 0 of this line, because if you look at gradient as the rise over the run, there's definitely rise. There's no rise, but there's definitely a run. So it doesn't matter where you are. There's no rise and run, so 0 over infinity will give you 0. So there's no x's involved, because it'll be mx and gradients to m, so we get 0 for our gradient. So that means that we just get the equation of y is equal to 3. So any line that's parallel to the x-axis will have a gradient of y, we'll have an equation of y equals to some number. Y equals 8, y equals minus 6, y equals minus 10, and we draw it up accurately. Even the x-axis, that's y is equal to 0, because on the x-axis, y is always equal to 0. So x doesn't matter what the x value is, it's got no part in it. So horizontal lines is y is equal to a number. And that's the opposite for a vertical line, because if you have a look at the point here, doesn't matter where we go, 2, 2, 2, 4, 2, 6, 2, 8, 2, 10, 2, 0, 2, minus 2, 2, minus 4, 2, minus 6. Every x value along there is equal to 2. So y's got nothing to play with it, play in here. So we have x is equal to 2 every time. So that's why if you see a vertical line, it's going to be in the form x equals to a number, because it's going to have to go through a particular x value, and the coordinates of all those x values will be the same. So that's why we're able to get those two particular special lines. So be aware when you do see these, and what do they mean, and you're able to accommodate the questions that are involved at that time.